Hello students, Dr. Mike here. This is for my CIS 2640 Network Security / Security Plus course. And this is topic 10. In this case, the time of this recording is week 10. It's mobile and embedded device security. As usual, be sure you check your current course shell for any changes to both when this topic appears and any changes to any assignments that may be referenced in this quick demonstration. So again, this is currently chapter 10, and which is mobile and embedded device security in the text. We will, of course, not go through the whole chapter. Please look through the chapter for anything. I'll pull out what I think is some good content, and as usual, I like to share some external resources I believe will be very helpful with this content in real life. So again, cherry picking through the chapter here, mobile and embedded. Again, a lot of the chapter goes and talks about different types of mobile devices, and it seems like a review. Like, I know what a tablet is, I know what a smartphone is, and even I know what a smartwatch is, but you gotta really think beyond what all mobile devices are, and when does mobile and Internet of Things start to sort of cross over, and also beyond the person, vehicles, smart vehicles, for example. So this mobile device, Internet of Things, cloud is sort of growing, and it's encompassing more and more things, both in our home and in corporations. So let's understand the risks that can come from those, and we'll look at that here in the chapter. So again, normally a small form factor, some sort of mobile OS is an operating system. So unfortunately, we'll see with the IoT side of the house, this gets inefficiently patched and is usually littered with some basic security holes like default passwords, for example. So these things usually end up on the Wi-Fi, and then of course access across the net. So we're building a basis here that we need to look at, and this goes back to previous security topics, but everything's going to go back to the cloud somehow, unless you have something that reports directly back to your own data center. And even then, if you have your own private data center, if you're a big company and you built an entire data center and you have your own personal cloud, you still got to consider this device, whether it be a phone, tablet, something where it's going to talk to possibly another device locally. So let's draw a little watch here. I'll do my best job of drawing a smartwatch. This may talk to and from a device locally. So we have Bluetooth to consider. Again, going back to chapter 9. The tablet itself, and or this device, or the Internet of Things. Let's just draw some random box here, right? This is my best job at drawing a really bad looking box. This device, maybe it's a camera that's watching, for security reasons, ironically. All this stuff, maybe it's a home security, the Ring doorbell system, for example. All these things are going to talk to either something locally. Now the camera could be hardwired to a local network. Still, there's that to consider, that connection. It can be tampered with physically, or is it using Wi-Fi? In that case, how's it connecting to Wi-Fi? And of course, mobile devices themselves talk to and from the cloud and to each other. So we have this transport here, this layer, right? Our transport layer here. Is it done securely? So, and of course, how's it stored securely in the cloud? How's it stored securely on the device? I say how, I mean the data. So, and then what is being shared out here? What data is being shared from the device itself? So, gotta consider the data. I know I'm jumping ahead, but that's the thing to really consider. What is the data that is being shared and has to be protected? So again, the device itself can come in all shapes and sizes, and it's sometimes from now, maybe a year, 2 years from now, there'll be different devices now that I haven't even talked about. So again, tablets, I'm not gonna go over that. Smartphones. Just consider again how it talks from that slide. The reason why I kind of kept it was not just the cloud, but also could we be talking to, again, let's just do a LTE tower here. My best job at drawing a radio tower. And if you're dealing with really high-end security, there's those little portable LTE towers. I know I've been to DEF CON in Vegas, and um, suddenly you get extra LTE towers popping up. So there's known to be issues with this too. So now as they go to the cloud, the devices that talk to LTE and back and forth. Again, and what the data itself is: it text messages, voicemails, video, web. So again, this comes to all types of things. Fitness trackers, for example. I do have an example here. What looks like benign data to most people. I say benign. It's data. I'd say, well, okay, this fitness app, and this is from 2018, so this is already a couple years old, but it's a great example of the sort of the hostile use of what looks to be just benign data that is emitted from a device that's wearable. So soldiers in this case at a secret base, their running tracks were being routed. Now, if I was a terrorist, this could be of great interest. I can figure out entrance and exit ways. Maybe there's ones that aren't normally physically under physical surveillance. You assume the front gate, but you realize there's a side gate now that the soldiers have been using. It has less protection. There's no camera there. So also the fact that maybe if I want to do any physical harm, where are these soldiers running from, and I can capture a soldier, kidnap somebody. So this data could be used for things in a very hostile way. So that, again, looks like normal data could be bad. So again, what data is being leaked? What data itself it is? Not I say leaked, emitted from a device, and then how's it being emitted, and where's it being emitted to, and how's it being shared? So portable computers, I'm going to skip past this. We know this stuff. I would say portable computers, anything portable, physical protections on these devices. Again, probably the number one thing is these get lost and stolen. Do they have any sort of authentication, hence a passcode? And if so, what kind of passcode is it? They have biometrics. Biometrics can be good in personal use because it allows me to keep a strong passcode, but easily access my device as myself. So I get that nice balance between good security and usability, which usually don't balance out. However, maybe it's a government-led thing. You don't want to use any biometrics at all, so that's something to consider. For whatever reason, you don't want someone to be able to take someone's thumb in whatever method and use it against a device. So how the device is accessed, how the device is secured, and of course what's on the device should be utmost number one thing. What's on the device, how's it protected? So that protection of data also comes down here to on the device itself. How's it being protected? How's it being transmitted? How's it being shared? So these are the questions you should ask when doing some sort of audit for a company, maybe for your company, or you're hired to do an audit for mobile and embedded devices. So infrared's what I talk about. USB connections, that's number two. Devices allowing USB connections, mobile device management, which we'll see here. And of course, what model is your company or the company you're working with using for devices? Are they doing corporate-owned devices? Are they doing BYOD, bring your own device? And we could talk about that. There's positive, negatives for both. And this is really going to depend upon the company, the institution. Is it a government agency? We don't even going to allow mobile devices. I mentioned before, I'm going to mention here somewhere that I went to the FBI lab in Cincinnati, the forensics lab, and I couldn't even bring my Time smartwatch and my device. All this stuff would be checked in when I got my visitor's badge. So, do we allow devices at all? Do we allow USB keys? There's some places on the base I know that don't even allow anything to be brought in. So and these are administrative, policies that should be part of your auditing, and how they're enforced. So the example of the FBI was when I went to check in, the security guard has a physical checklist, and their checklist says, do not allow any mobile devices. You have mobile devices on you. Yeah, here's my phone. Okay, we're going to check it in. Here's a receipt for it. You can have it when you come back out. So Again, not everything is going to be technical in nature. Look at administrative use. How do we handle these things? And this is going to depend upon, again, your deployment model. If it's corporate owned, do we have any mobile management on it? So again, think of mobile device risks. There's a lot of them. Untrusted content, deployment models, things like that. So the chapter will go into that. Physical security, talked about that already. Connection vulnerabilities. Again, how are these things connected? Again, how's this device allowed to connect to the outside world? Can I plug a USB into it? And if I do, what can I see from that USB connection? That's supposed to be a question mark. And do I not allow that at all? Turn it off within the OS, and then have that locked down only behind a passcode that's admin controlled from our own company that controls it, maybe. Or maybe it's we allow personal devices, but somehow we want to be able to allow our salespeople to allow and view access, have view only access to sensitive data, but we don't want the data to be held on the device. So we keep either a sandboxed app that has a view only portal that has an additional authentication to that sensitive data in the cloud. So there's different approaches here. So again, it really comes down to this: the data. There's so much that this revolves around. If the device is a workout device and it tracks, again, as you saw in the article, it tracks your workout data, but it's not being sent to the cloud, but it's only kept local. Do we need to have encryption on it? Do we need to have, what level of security we need? It would be different than a device that's owned by a CEO, CIO, CISO, whatever, executive-owned mobile device that might have contact information, sensitive corporate data. The things that go about to protect that are going to be different than, per se, maybe this camera. So how's it connected? Configuration, again, think of it as this is no different than we looked at with system security in the previous chapter. Are there apps that I don't need? Remove them. Can I remove them? Can I turn on certain services? Do I need to have Bluetooth at all? Maybe you don't, so you disable it by default. Again, maybe lock that behind an admin type of account, like Chromebook Manager, for example. Maybe you can turn on or off certain things. Again, and this is probably really the encryption. This goes back to the encryption topic. Data in transit, data at rest, data in processing. How's it being protected? We should be using, of course, the latest. We're using TLS for this connection. So if you're doing a mobile device app testing, really part of your testing is going to become probably an API. This is probably an API up here on the cloud. An API test, web app pen test, is part of this, really. So it goes beyond the device. The scope of it goes into the cloud. So if that device touches the cloud. And of course, part of that would be how we test that. So you can maybe hook up, for example, maybe I've done this before, given a mobile device to test with an app. Create on my Linux laptop, create a hotspot, and then pipe that hotspot through Wireshark, and then hook only this device up to that hotspot, eliminate the amount of noise, because we know Wireshark can be very noisy, picks up everything, and then go through and log in, and stop Wireshark, save that packet, a PCAP file, and go back and look at it. Is that login? Is there anything that's insecure? I should be seeing, of course, TLS being used, maybe how it's the initial connections that are made, and when I hit login, there's no way I can sort of scrape out username and password from anything. And then go to the second part and use the app itself. So Wireshark's great for that. Capture those PCAP, that data, and you can analyze it. So that's an example how you would test for that. Data at rest, of course. How is it being held? Is to look at the development documentation, designer documentation, or even get in and see if I can get onto the device and get into the sandbox stuff. I'm going to give you a hint. There's places I've encountered doing mobile pen testing where the app itself is sandboxed, but there's a publicly accessible cache file, and these cache files are binary. Well, I push the cache file through something called strings on Linux. Strings command. It pulls on any ASCII strings. And unbeknownst, I see a base 64 string. Well, it's base 64. It can be decoded. Decode it, find out that's my username and password. I used to log in. It was in the cache in base64 encoding. Find out the development doc said they were encrypting with base64. Give you a moment to think about that. Encrypting with base64. That's not encrypting. So there was a design flaw, which goes into the previous chapter. That design assumption went into, and then there was the use of caching that was never thought about. Again, it's not malicious in any developer end. They just either came in and told use base64. Okay, they'll take the input, they base64 it, and then it goes to the cache. It's just part of the regular library function for the Java app. It builds a cache. Unbeknownst, my base64 credentials are now sitting in a publicly accessible cache file. So it's those sort of things you got to really watch out for. So encryption, definitely make sure it's being used. And then support tools. Application management, device management, and content management. Again, I talked about before how we manage what's accessible to devices over maybe an app we develop or an app we use for a third party, maybe Google Docs, for example. How can I manage those? The idea being what's left on the device. If the whole full file is downloaded, then that file is downloaded and accessible on the device, even if it's shut off. And someone gets the device, it's stolen, or it's found, lost in an airport, and it has poor security, physical security. Maybe it does have a lot of USB connections. Again, how's that file being, how the application is accessing a file, and how's it being managed, the content. And of course, mobile device management is a huge area. MDM, there's an entire, both iPhone, Android have ways to do MDM. Chromebook does too. There's third parties who help with this. There's probably open source and both paid solutions. I'm not going to go into those here. They exist though, and you should be looking at those if you do have some sort of device management ability for devices for the company. So app security, again, we can whitelist stuff, geofence things. This is actually a good one. Geographical boundaries. If it's a mobile device, we're not going to allow the device to log in if it's outside of a certain IP or GPS area. So again, these can be spoofed or hacked, but it's about layered security. So let's end that with, that's the mobile device part. Now with embedded devices, it's not much different here. We'll just take away this and we'll keep this up here. Let's go back to our doorbell. Maybe it's Ring doorbell. Maybe it's an internal, a camera on site or cameras that connect over wired. Maybe it is a camera system, but maybe it's connect over Wi-Fi. And maybe it's a personal use, or maybe it's a personal use normally. Like again, I'm not picking on Ring, but I am. So Ring doorbell or one of those, and it's connected to the cloud. How's it connecting? Again, and what's the data? That should be the number one question. What data is being transmitted, and how's the data being stored? Now, problem with these things versus a phone. Both Android and iOS, Apple, do a really good job at managing patching, app security, device security. I think it's definitely way better than a Ring doorbell camera we've seen in the past, or even worse, a cheaper embedded device. And first off, you got to be able to identify these embedded devices and Internet of Things. I'm really going to talk about the same thing, but these can end up a lot of places. Aircraft, vehicles, industrial machinery, HVAC controls. So we see a lot more stuff being connected to our network, and these things don't have the same level of patching and management and security inherently built into them as we see with laptops, Chromebooks, and mobile phones. So you got to really watch how these are connected. It could mean restructuring a network, having a IoT only subnet, IoT management, things like that. So, ICS, industrial controls, and SCADA. This is definitely the ones that usually have the largest things. And this is nothing that if you walk into a company and you're the information security engineer, and it's a manufacturing company, SCADA should be on your mind. And you're not going to be left holding the bag new. NIST, and this is actually a year old now, actually just over a year old from when I'm typing this recording to 2020, but they have guidelines for IoT devices. So again, look at NIST, look at OWASP. Why is that? Again, it is an API, right? This is an API connection, this is a data connection. I can look at OWASP security at this area. I can look at physical security here. I can look at network in the previous chapter. Look at my Wi-Fi security here. Look, it's a mobile device. It's a tablet or notebook. MDM management. And again, all these should come down to this right here. This should be the key thing. What data is on the device? What data is being transmitted? How's it being processed? But again, and we have guidelines for those. You bring those in. And then we have guidelines now for more IoT, identification, configuration, protection. Again, data protection right there. NIST has these as well. If you just go to the NIST search page and I search for the word mobile, look at this, security guidance for first responders, mobiles and wearable devices, accessing threats to mobile devices. So you're not coming into this with a blank page. I can't say enough to look at this documentation. And even if it's draft, like this one, that's fine. You can probably go through this, and I can probably extract stuff that we can build our own little checklist, our own audit checklist from, and reference this too. So when I'm audited, maybe for other reasons, maybe ISO audit, any ISO standards, whatever, where'd you build your audit checklist from? I got these items from a NIST publication. It's going to look good. It's going to look good to your higher ups because they go, oh, okay, NIST is that government thing where it's all about security. Well, good, we're using that. Yeah, we're going to farm. We farmed or basically copied, stuff from this directly that apply to our then. So here's SIM modules, for example. How are we going to handle those? So Wi-Fi, Bluetooth. So again, you don't have to go through this with an empty page. And just search for mobile in the NIST search portal. And there's a lot of stuff here. Usability considerations for public safety, mobile authentication, and so on. So, and SCADA should be the same thing. Look for IoT. Look for NIST publications on IoT. Core archives for basic secure Iot Devices. There you go. It's obsolete. Now this is here. Okay, here we go. So now we have Iot and Device Manufacturing. So again, I'm not going to read the document to you, but we have a basis to start from. SANS might have some stuff too. I'm really going to lean on NIST and OWASP. This being probably your first stop. OWASP for considering this part of the whole solution. Anything that's going to go to a cloud or a web, even if it's here, if it's a web-based interface, is it going over an API? We need to apply those web-based pen test or integrity checks up here too. So, and then back on the code again, code security. So again, here we have guidelines for these SCADA devices. And why is this important? Again, look at this vehicle. This is from the chapter. I mean, there's a ton of stuff. Car hacking has been huge the past few years at DEF CON, and for a reason, because our cars are becoming more and more connected. In fact, I think the latest BMWs are going to have always-on connections, but also even physical connections. How can we get in the car? The wireless keyless remote, things like that. Also embedding looks at system at chips, real-time operating systems. Again, there's an operating system somewhere in this device, whether it's a vehicle or it's the camera, or in the case of this right here, a thermostat. This is from 2018, so this is an old article, but it still is a great example of how a connected fish tank thermometer. Again, we want to connect these things, and then you want to connect them for a reason. We want to be able to harvest that data, monitor for issues. I mean, this is a real fish tank that's being monitored. It's a very expensive piece of fish tank there. You want to make sure it's, the fish are healthy and it's healthy. So it makes sense to connect this, but that's that chink in the armor And this is how someone can find that fish tank monitor. Maybe it's this is this little thing right here from the outside world, and maybe it has a Wi-Fi connection it's unbeknownst exposed, even though it is connected to a hardwire. We left the Wi-Fi on. Maybe it has that internet connection to the world, and it has a weak API or a weak framework, or it has a default password that has not been changed. So it has a known vulnerability that is not patchable unless you remove it and buy into the new version. That could be an issue, and as if there have been issues before with that, because there's a lot of money put into security for these things, and it could be just version 2 that came out that costs twice as much, just have better security, and you get to go back and replace this. So again, back at design, if you can look for ask these questions before you go out and purchase your fish tank or HVAC monitoring solution. Look at NIST, look for guidelines. Right there, when's end of life occur? How you support the device? These are questions you can ask the retailer directly, or maybe it's the vendor. Corner them, ask them, email, phone call, a meeting, something like that, a face-to-face meeting. You need to have this, especially with high security. You got to have these things up front. So this gives you, again, this NIST documentation gives you a great way to build that list of questions to ask. Again, IoT is all kinds of places. Again, this is where wearable and IoT, really mobile and IoT really do sort of cross each other. If you Venn diagram those, there's some overlap. Wearables is a good example of that. Body area networks. Again, this is probably the number one thing. IoT vendors are concerned with making it inexpensive, and security is left out. So that's it. So yeah, IoT is a very big thing to do, but you're not alone at that. Look at NIST. Look at NIST. Look at how it connects. And again, probably utmost with any device, mobile or embedded. Look at the data. How's it protected? So that concludes this chapter. Hope this is helpful. Thanks.